Hi students, this is AJ sir. Let's study 9th standard ICSE Math, Chapter 11. Inequalities means either greater than or less than. This is a geometry chapter, so we need to write proper statements and reason for each step. Theorems proving will not come in exam, but we need to know the statements. If two sides of a triangle are unequal, then the greater side has a greater angle opposite to it. For example, if this is 33 degrees and this is 40 degrees, then the side opposite to 33, which is AB, will be smaller, and the side opposite to 40, that is CB, will be greater. Theorem 4 is the converse. That is, if two angles of a triangle are unequal, then the greater angle has the greater side opposite to it. So if BC is greater than AB, then the angle opposite to BC, that is angle A, is greater than the angle opposite to AB, that is angle C. So angle A is greater than angle C. Now, since there is only one triangle here, we can label it as just angle A. But if there were multiple triangles possible in any diagram, then we need to give the name as angle CAB. Use a three-letter naming. For example, out here, if I am trying to prove something, I can't just call it as angle A, because angle A could be the total one or the smaller one. We need to be specific in such situations. We need to mention it as angle DAB. Similarly, for angle D, please give a three-letter naming, because there are multiple angle Ds. Even this is angle D, so is this one. The next theorem says that of all the lines that can be drawn to a given straight line from a given point outside it, the perpendicular is the shortest. Which means that if this is a line and I just give you a point and I want to know the shortest route between this point and this line, it won't be this one or this one, it would be the perpendicular one. That's the shortest route. Now for some corollaries. The sum of the lengths of any two sides is always greater than the third side. That means this plus this has to be greater than this. If this is 3 centimeters and this is 6 centimeters and I say that this is 8 centimeters, this is impossible. There's no way you can ever draw such a triangle. I'm sorry, not 8. Let me put this as 10. Yeah, there's no way you can ever draw such a triangle, because 3 plus 6 is 9, and the sum of any two sides has to be greater than the third side. And the second corollary says that the difference between the lengths of any two sides is always less than the third side. So now even such a triangle is not possible, because 8 minus 5 is 3, which is greater than the third side too. That's not possible. The difference between any two sides has to be less than the third side. Now let's start with exercise 11, the second sum. In a triangle, QR is equal to PR, so it's an isosceles triangle. One angle is given. Which is the largest side of the triangle? Now in every sum you have to draw the diagram. It's compulsory. But you can use your free hand and a pen. No need to use ruler and pencil. Just draw it like I have. If you can draw bigger diagrams, it's better. Even while solving solved examples, make sure you draw the diagrams. No need for pencil and ruler. You can draw it freehand with a pen or pencil. No need for ruler. Even in exams, you can draw freehand. Only if there is a construction sum, then you have to use a proper ruler and compass. So here, this side is equal to this side, and this is 36 degrees. If the given is given in the question, then there is no need to copy the given. But if the given is not given, then we need to write the given. As we solve more sums, you'll understand this better. So I directly started the solving. In triangle PQR, always mention the name of the triangle you are referring to. This angle is equal to this angle 36. So even this will be 36, isosceles triangle property. If you don't write reasons, you lose marks. And the sum of all angles is 180, angle sum property. So I got angle R as 108. Now that I have all three angles, I can now decide which is the greatest side, and indeed QP will be the greatest side because it is opposite to the greatest angle. Now in question 4.1, we have to arrange BC, AC and CD in the ascending order. Ascending order means smaller to bigger. So which one is the bigger side? We'll have to first find the respective angles, and looking at the angles opposite to these three sides only can we decide which is greater than which one. But keep in mind there are two separate triangles, so we'll have to solve this sum into two parts. BC, now the angle opposite to BC is this one when we are talking about the smaller triangle. Then the angle opposite to AC is 33 degrees for this triangle, and this is the angle opposite when we are focusing on this triangle. And the angle opposite to CD is this angle when we are focusing on this triangle ACD. That means I should find the values of this angle, and this angle respectively. So first of all, it's an isosceles triangle. So if this is 67, then this is also 67. So by angle sum property, I can find this angle as well. Then by linear pair, I will find this angle, so that by angle sum property, I can find this angle. So that's how I find all the angles. So here, these are the steps. This is how you have to solve with reasons. Here, if this is 67 and this comes out to be 46, by linear pair this comes out to be 113, and by angle sum property this is 34. Now in this triangle ABC, I can say that BC is greater than AC. BC is greater than AC because the angle opposite to BC is greater. I'm sorry, I got it reverse. Angle opposite to BC is smaller to the angle opposite to AC. So we can say that BC is smaller than AC. See here. BC is smaller than AC. Why? Because angle BAC is less than angle ABC, and that's the theorem we studied. 67 is bigger than 46. Which side is opposite to 67? AC. Which side is opposite to 46? BC. So which is bigger? AC. Always mention the name of the triangle you are referring to. Now let's talk about the other triangle, ACD. Notice how in this triangle I was using single letter angles because I've already mentioned the name of the triangle. So even if I say angle C, there is no confusion because in this triangle there is only one angle C. If you still wish to use three-letter naming, it's okay. Now in triangle ACD, linear pair, this is 113, this is 34. So which sides are we asked to compare? AC and CD. AC and CD. AC opposite to that angle is 33 and CD opposite to that angle is 34. 34 is greater than 33. So which side is greater? CD is greater than AC. Or AC is smaller than CD. So I just proved that BC is smaller than AC. And now I have proved that CD is greater than AC. So in ascending order, if you look at 1 and 2, it seems that this is the smallest, this is a little bigger, and this is the biggest. So that's the correct order from the two equations. Now in the sixth sum, D is a point inside BC of a triangle. So the diagram is like this. So on side BC, I just put a point D. It is given that AD is greater than AC. And I have to prove that AB is also greater than AC, which is very clear by looking at the diagram, but we have to prove it geometrically. So first of all, focus on the smaller triangle ADC, where AD is greater than AC given. That means the angle opposite to this angle is greater than this angle. But this angle is definitely greater than this angle, because this angle is an exterior angle for triangle ABD, and you know exterior angle is always a sum of the remote interior angles. That means this angle will definitely be greater than this angle. So if this was greater than this and this is greater than this, that means this angle is greater than this angle. That is, angle ACD is greater than angle ABD. Now in the big triangle, if I say this angle is greater than this angle, then which side is opposite to this? This one. And which side is opposite to this? This one. So clearly this side is greater than this side. Side opposite to greater angle is greater. Write the reasons, don't forget it. Now in the eighth sum, this entire angle is 110, okay, entire angle. And this is 74, this side is equal to this side, so that's an isosceles triangle. We have to prove that BC is greater than CD. Now BC and CD are not two sides of a common triangle, so we can't directly prove them, prove this to be greater than CD. I need a connecting link, and that connecting link will be AC. You see, BC and AC belong to one triangle, and AC and CD belong to another triangle. So step by step I can prove BC greater than AC, and then I will prove AC greater than CD, hence proved that BC is greater than CD. In fact, I beg your pardon, I will prove BC is greater than AC, but here in this sum it is given that AC is equal to CD. That means if I can prove BC greater than AC, I can simply say that BC is greater than CD. I can just replace AC with CD because they are equal. But how do I prove BC greater than AC? How do I prove that? That means I have to prove this angle is greater than this angle. So how do I prove this angle greater than this angle? If I can prove that, then the sum is over. That means I have to calculate this angle and this angle. So that's the logic behind such sums. First, find the angles. So first of all, it's an isosceles triangle. So let me assume this to be X and this angle also to be X. Now exterior angle property 74 is equal to X plus X. So that way we can get the value of X as 37. We can do a longer method also, like linear pair and then angle sum property, but I prefer exterior angle property of a triangle. So this is 37 and this is 37. Now if this is 37, then this will be 110 minus 37, which comes out to be 73. So I got this angle. Now in angle sum property 73, 74, I can find this angle, which is 33. So there you go. This is 73, this is 33. This angle is greater than this angle. That means BC is greater than AC, but AC is equal to CD, hence BC is greater than CD. Now solving the sum in the diagram is easy, but now writing the proper statements, that's the most important thing. So have a look at all the statements. Make sure you write all the reasons exactly the way I have solved. Don't try to solve on your own. At least these sums which I am solving, you do as I do, so that you are trained enough to do the remaining sums on your own with proper statements. And now the remaining statements. Mark this 8th sum as IMP. In the 10th sum, we have to prove these things for a quadrilateral ABCD. So, in this quadrilateral, draw the diagonal AC, first of all. Now, I know that this plus this is greater than this, but this plus this will be greater than this. You see, in any triangle, the sum of two sides is greater than the third side. So, I got two inequalities here, inequalities. So if this plus this is greater than this and this plus this is greater than this, so from equation 1 and 2, obviously this plus this will be greater than AD. If it's not obvious to you, then let me show it to you. Let's add equation 1 and 2. So first let me write LHS AB plus BC plus AC plus CD. I've added the LHSs. Now there is a greater than sign. Let me put that. And let me add the RHS, that is AC plus AD. Okay, so LHS of both the inequalities and RHS of both the inequalities. AC cancelled. Yes, we can do that. So I got this. So if you want to show this step, you can. For proving Roman number 2, we will now again use triangle ACD, but this time we'll say that this side plus this side is greater than this. And when we add equations 1 and 3, let's add equations 1 and 3. First of all, the LHS, AB plus BC plus AD plus CD, and the RHS is AC plus AC, that is 2AC, hence proved. And for Roman number 3, all you need to do is draw a diagonal BD and follow the same method of Roman number 2. So I'm going to simply write similarly and this. No need to prove it again. Now in the 12th sum, P is any point inside the triangle. So we draw it like this, and we have to prove that this angle is greater than this angle, which is clearly visible, but let's give it a geometric proof. Construction. We will join AP and extend it to point D, and whenever we do a construction, we have to mention it, we have to write it. So I've split this into two parts. Now this angle is the exterior angle of triangle BAP, and you know exterior angle is equal to the sum of the interior opposite angles. So definitely this angle is greater than this angle. Similarly, this is an exterior angle of triangle CAP. So this angle is greater than this angle. So if this is greater than this and this is greater than this, that means this total angle is greater than this total angle by adding these two inequalities. So here are the statements. You can pause it, you can solve it, and then go ahead. Students, here the diagram is given and you have to prove certain things. Since the given is given, no need to write the given. Of course, we have to join DE, but that's what they've mentioned in the question itself. It's not a construction. We have to prove BE is equal to DE. Equal to, not unequal. That will be possible by CPCT. So we'll have to prove two triangles congruent. So let's take triangle ABE and triangle ADE. Here, this side is equal to this side given. This angle is equal to this angle given. And this side is equal to this side, common side. So these two triangles are congruent by the SAS test. Write all the statements. Hence, BE is equal to ED by CPCT. Next, we have to prove that this angle is greater than this angle. Well, first of all, we know that this angle is equal to this angle, isosceles triangle property in triangle ABD. Always specify the triangle under consideration. And this angle is greater than this angle, because this is an exterior angle for triangle BDC. An exterior angle is always greater than a remote or interior angle or interior opposite angle. So if this is greater than this and this is equal to this, then this is greater than this. Proved. Look at the statements to be written and the reasons. Now in the 16th sum, it's given that AB is greater than AC is greater than BC. That means the respective opposite angles will be in that order. So this will be the biggest angle, second this, and this will be the smallest angle. Now this is 180 minus Z, it's a linear pair. This is 180 minus Y, that's a linear pair. And even this is 180 minus X, that's a linear pair. So on solving, because of the linear pairs, I'm getting 180 minus Z is greater than 180 minus Y is greater than 180 minus X. 180 subtracted from all the brackets, what is left is this. Now the thing about inequality is whenever we multiply or divide by a negative number, that is whenever we remove the negative sign, the inequality flips, it changes. So that is the final answer. Now in 17th sum, there is a quadrilateral whose longest side and shortest side is given. And we have to prove inequalities of the angles. So in such a sum, we should do a construction of the diagonals. I'm doing Roman number 2 first, but you could very easily do Roman number 1 in the same way. So I'm constructing diagonal BD and I'm labeling the angles as 1, 2, 3, 4. In this triangle, I know AB is the longest side. So definitely AB is greater than AD. It's given. That means angle 1 is greater than angle 2 because opposite to greater side. Similarly, in triangle DBC, DC is the shortest side. That means BC is greater than CD. That means angle 3 is greater than angle 4. Now adding these two equations 1 and 2, I'm going to get 1 plus 3 is greater than angle 2 plus 4. That is entire angle D is greater than entire angle B. Hence proved. And Roman number 1, you can simply say similarly. If you want to prove this first, then you should draw the diagonal AC and solve in a similar way. Next, in the 19th sum, an isosceles triangle is given. It is also given that the sides AB and AC are equal, and on the base B there is a point D, and when BC is extended it reaches point E. The diagram is not given, but the labelings were given, so we don't have to write the given. Now, first of all, in triangle ABD, you see I have to prove Roman number 1, I have to prove that AC is greater than AD. AC greater than AD. So first of all, I'll prove that AB is greater than AD. And AB is equal to AC, isosceles triangle. Hence, it will be proved that AC is indeed greater than AD. So the first things first, this angle is greater than this angle because it's an exterior angle. But this angle is equal to this angle, isosceles triangle. That means this angle is greater than this angle. Well, that's just perfect. So now I just have to focus on one triangle, ADC. No need to talk about triangle ABD now. I just proved that this angle is greater than this angle. That means that side AC is greater than side AD. So that's Roman number 1. Now in Roman number 2, I have to prove that AE is greater than AC. I just proved that AC is greater than AD. But now I have to prove AE is greater than AD. So first of all, this angle is greater than this one. It's an exterior angle. See, whenever you write such statements, you have to mention the triangle you're talking about. In triangle this, in triangle this, in triangle this. So first of all, this angle is greater than this angle because it's an exterior angle of triangle ACE. Also, this angle is greater than this angle because this is the exterior angle of triangle ADC. Now, this is greater than this and this is greater than this, but we have already proven that this is greater than this. So, from equations 1, 2 and 3, we get that this angle is greater than this angle. Actually, this should be Roman number 2, and we just need Roman number 2 and 3 in equations to prove this. This Roman number 1 I had just written thinking in case it is useful. So again, I said that this angle is greater than this angle, and this angle is greater than this angle, and this angle is greater than this angle. Hence, this angle is greater than this angle. I repeat, angle ACE is greater than angle ADC, exterior angle. But angle ADC is greater than angle ACD, as proved in Roman number 1. But angle ACD is greater than angle AEC, again exterior angle. So this means that angle ACE is greater than angle AEC. That means this side is bigger than this side. So that's how you prove Roman number 2. And now Roman number 3, well, that's obvious from the first part and the second part of the sum straight away. I have proved that this is greater than this, and now I have proved this is greater than this, so it follows that this is greater than this.